Let's create a DFA for the language W where W doesn't contain the substring 110. So what are we exactly looking for when we say this language? Well, we're looking for an input string essentially consisting of zeros and ones, because this is our alphabet here. 0, 1 means that we could have a bunch of random zeros and ones in an input string. What we're looking for is this substring 110 inside this input string here. So we can see we have 110 here, and then we have another 110 right here. So this would fail the criteria because it has the substring 110, but we want a string that does not have the substring 110. Now, if we had a string like 00011, well, this would pass because we don't see 110 anywhere inside here. Perfect. So if we are creating a DFA for this language, we can start with our initial state 1. And what we want to do here is the logic for finding the substring 110 is we're going to have a sequence of events here. For 110 to exist, we first need a 1, and then we need another 1, and then we need a 0, all right after each other. So let's create some transitions. We'll have a transition on 1 to a new state, then another transition on 1 to a new state, and then another transition on 0 to a final state. We can name these states accordingly, 2, 3, and 4. Now what this does is if we have an input string, say we have input string 110, what this is going to do is we're going to have our first character in the input string fed into the DFA, so that's a 1. So we're going to find the arrow for 1. We're going to follow it. So we're going to go from state 1 to state 2. Then our next character is a 1, so we follow the 1 arrow to state 3. Then we have a 0, so we follow the 0 arrow from state 3 to state 4. So what this is telling us is that if we are on state 4, that means we have the substring 110, or we just have the string 110. However, it's not always going to be this simple. I wish that we were just fed in this string every single time 110. Well, we would just know that that's not the case. But we have a bunch of other stuff inside the string, so we're going to have 10100011011. So how do we account for all these extra characters? Well, what we can do is kind of create, this is where the algorithms come in. This is where DFAs are helpful. So if we have, say we have a 1, which is ideal, that's what we're looking for. The first thing we're looking for in the substring 110 is a 1 to occur. But what if instead of the next 1 occurring, we have a 0 instead? Well, we want to essentially go back to where we started, because now this 0 ruined our entire string, and now we need to look for 110 all over again from scratch. So this is telling us on state 2, if we see a 0, we're going to go back to where we started on state 1. And now what if we have, so we've kind of accounted for 10, the input string 10. So we start at 1, we go to state 2, and then on the 0, we go from state 2 back to state 1. We're basically just starting over. What if we start with a 0? So what if we have 0, 0, 0, 1? Well, these zeros are not really relevant, because for 110 to exist, we need first for a 1 to occur. So once the 1 happens, then we can start looking for 110. But if we just have a bunch of zeros, there's no point in looking for the substring 110, because we need a 1 to be the first character to kind of activate our, wow, like these next 2 characters could be a 10, and then that would create 110. But if we just have a bunch of zeros, that's not possible. So therefore, we can just loop on ourselves on 0. So we just stay in place. If we have a bunch of zeros at the beginning, we just stay in place and we don't do anything. But then once we see a 1, then we move over to state 2, and then we start looking for our 110. So, okay, this accounts for a few test cases. What if we have 1, 1, and then instead of a 0, like we ideally should have, what if we have a third 1? So we have 1, 1, 1. Now this is a little bit interesting, because you might think that we want to restart and go all the way back to the beginning, or go back a step. But this one's interesting because if we have 1, 1, 1, 1, 1, 1, 1, and we keep having a bunch of 1s, and then we have a 0, well, we still have 110 right here, and we're still going to fail. the amount of ones before the 0 doesn't matter as long as it's more than 2 ones, and we require 2 ones to get to this spot anyways. So what we can do is just loop on state 3 on input 1. And this is because, so we can have the input string 110 and then jump 110, or we can have something a little bit more annoying like 1111, and then we can just go 1 1, stay in place, stay in place, stay in place. We're gonna just keep staying in place, and then once we see that 0, then boom, we know that we have 110 by default, because like we already required 2 ones to get to this spot. And then once we're on state 4, that this is the state where we know we have the substring 110. So what we can do is we can just loop on everything. So we can loop on 0 and 1. Whatever happens after a 110 is not really relevant. So say we have 0 1 1 0. So we found our 110. We're on state 4 currently. Then we have a bunch of 1s, 0s, just a bunch of random characters. These do not matter. These are irrelevant because we already know that we're gonna fail our language here because we found 110. So what we're gonna do is we're gonna have this as our reject state. Being on state 4 means that we have the substring 110, but that's obviously the opposite of what we want. So every other state should be an accept state, meaning that if we're on states 1, 2, or 3, that means that we do not have the substring 110, and then that's good. That's what our language is asking for. Now, this is the final DFA for this language, but if we were to say we had the component of the language where it's asking for W contains the substring 110, well, what we would do is we would copy this diagram, but then we would inverse the accept states. So basically we would have an accept state on state 4 and then none on the others. That would be for this language here. And how we would edit it that's called the complement, when it's kind of like the inverse. But that's not relevant to the specific problem, but you might encounter it sometime, and that's how you would solve for it. But anyways, this is the final DFA for the language W, where W doesn't contain the substring 110. I hope this helped, and I hope it made sense. If you have any questions, please feel free to comment down below. I try to answer everything, and best of luck with what you're using this knowledge for. Thank you for watching.